Hello, good morning, all. So today we are going to learn organic chemistry. First lesson in organic chemistry: haloalkanes and haloarenes. Okay, what do you mean by haloalkanes and haloarenes? Here, alkanes with the halogens attached. So that is haloalkanes. Okay, alkanes, alkanes with halogens halogens attached. So this is haloalkanes. That is RX general formula. Okay. If you want to give a specific, so we can give this like this. So CH3Br or C2H5Br, anything. Okay. So this is haloalkanes. So in the same way, if arenes with the halogens attached are called haloarenes. Arenes with halogens halogens attached or called haloarenes. So that means arene means it's an aromatic compound, benzene. So if Cl is attached with this is haloarene. Okay, so that means the replacement of hydrogen atoms in a hydrocarbon, whether it is an aliphatic or aromatic, by halogen atom results in the formation of haloalkane and haloarene. Okay. Uh, okay. So here haloalkanes, which contains sp3 hybridized carbon atom of alkyl group, whereas haloarenes contains uh, sp2 hybridized carbon atom of an aryl group. Okay, so this is uh, what it's a haloalkanes and haloarenes. Okay, so uh, why do we learn this haloalkanes and haloarenes, and what is the use of these compounds in our daily life? Okay, so why we have to learn this haloalkanes and haloarenes? So we'll see why. Okay, why? So it is used as a solvent. It is a very good solvent, and it is used as medicine like antibiotic. Okay, it's medicines. It is antibiotics, and it is also used for making artificial blood. Okay, artificial blood, but the research is still going on for this one. Okay, research is still going on. Research is going on. Okay. Then it is also used to treat malaria. It is also used to treat malaria, typhoid, fever, and gout. Okay, so deficiency of iodine, goiter, and it is used as anesthesia. It is used as anesthesia, and it is also used as insecticide. Okay, insecticide. So these are all the uses in our daily life. So it is very important to learn about it, haloalkanes and haloarenes. Okay, so we will get into the topic. First, we will see about its haloalkanes. Haloalkanes. So if you take a haloalkane, uh, so here, so this is a haloalkane, yes, in carbon. So all these sides will be a hydrogen. So here this carbon, no, so this is sp3, sp3 hybridized carbon. Okay, sp3 hybridized carbon in haloalkanes. Okay, so based on this, so we are going to see classification of the classification of haloalkenes and haloarenes. Classification. First classification, which is based on the number of halogen atoms. It's based on it depends on number of halogen atoms attached. Number of halogen atoms attached. That is the first classification. So these may be classified as mono, di, tri, tetra, or poly, etc. Okay. Suppose if it is a monohaloalkane, okay, it's monohaloalkane. Example for this one is it's C2H5X. This is that means it's only one halogen atom is there. This is mono. In the same way, if it is a dihaloalkane, so that means two halogen atoms will be there. That is CH2X and CH2X. Trihalo, trihaloalkanes, three halogen atoms will be there. CH2X, CHX, and then CH2X. So this is one classification of haloalkanes based on the number of halogens attached. Okay. In the same way, so we can classify mono haloarene, dihaloarene, and trihaloarene for aromatic compounds. Okay. Haloarenes. If you take the haloarenes, if one halogen atom is attached with this benzene group, so this is mono. Okay, so this is mono. And if two halogen atoms are there in the if two halogen atoms are there, so suppose here it is one and here it is one, so this is dihaloarenes. Okay, so then if it is a three, it is three halogen atoms are there. One, two, and three. So this is trihaloarene. Okay. So monohalo compounds. So this is one classification of haloalkanes and haloarenes based on the number of halogen atoms attached. Okay. So this is one classification. Okay. I hope that you are following me. Um, if you have any doubt, so please clarify. Okay. Then next classification. Um, Next classification. This is first classification, and this one is the second classification. Compounds contain classification based on hybridization. Okay. Based on hybridization. Based on hybridization. So based on hybridization of the carbon atom to which the halogen is bonded to sp3 carbon. Okay, sp3 carbon. So this is the way. Okay, so that means suppose if the carbon is like this. Okay, um, suppose if the compound is like this. Okay, so this carbon, so this is sp3. Okay, so there is a subclassification is there under this one. So again, three classifications are there here. One is alkyl halide. Second one is lead halide. Second one is lead halides. Third one, it is benzylic. Benzylic halides. In all three carbon is sp3 hybridization. So the bond is single. Okay, the bond is single. Okay. So here we will see one by one alkyl halide, lalic, and benzylic. So this is based on sp3. Okay, so we'll see one by one. Um, First alkyl halide or alkyl halides. The first one is alkyl halides. In alkyl halides, the halogen atom is bonded to an alkyl group. Okay, bonded to atom, halogen atom is bonded to an alkyl. So alkyl group means R. Okay, so the compound is actually they form a homologous series represented by CnH2n plus 1x. This is a general formula. Okay, so again this alkyl halides no, so further classified as primary, secondary, and tertiary. Okay, tertiary compounds according to the nature of carbon to which halogen is attached. Okay, so we'll see what is primary, what is secondary, and what is tertiary. Suppose if you take a compound like this, C, so this is one, and carbon, hydrogen, this is C, then then so if you're seeing these compounds, yes, we can easily classify primary, secondary, and tertiary. So here, if you take this compound, okay, the first compound, here the carbon, halogen is attached with this carbon, no? So we'll call this as a star carbon. Okay, star carbon or alpha carbon, anything. So this star carbon, no, so which is attached with no other carbon. Okay, which is attached with no other carbon. Here, this is a star carbon. Here, the star carbon which is attached with one carbon. So that means alkyl group. Okay. So here, in the third compound, the carbon which is attached to two other carbons. Okay. So here, the star carbon which is attached with three other carbons. So based on this, we can say that primary, secondary, and tertiary. Suppose if the carbon, star carbon which is attached with zero carbon, either zero carbon or one carbon, so that is primary compound. Okay, so that is primary. So that means this is primary and this is also primary. So here zero carbon, here one carbon. Okay. Suppose the star carbon which is attached with the two carbons, then it is called it is a second. Okay, so this is called secondary, and here that is a secondary, and this one it is a tertiary. So because here the star carbon which is attached with three carbons, so it is called it is a tertiary compounds. Okay, so here the CCl, that is the star carbon decides. Okay, star carbon or CCl bond. So this one decides attached. Okay, this attached which decides the compound is primary, secondary, or tertiary. Okay. Besides primary, secondary, and tertiary. Okay. So this is the first classification. That is alkyl halide. Again in alkyl halide, again one classification, that is a primary, secondary, and tertiary compounds. Okay. Uh, then the we are seeing all these compounds under the heading of sp3 carbon. Okay, so again the second classification in this is allelic halides. Allelic halides. Okay, what do you mean by allelic? So allelic means uh, again, so this is also sp3 carbon and X. Okay, so these are compounds in which the halogen atom is bonded to sp3 hybridized carbon atom next to CC double bond. Okay, So these are the compounds in which the halogen atom is bonded to an sp3 to sp3 sp3 hybridized carbon, sp3 hybridized carbon atom, okay, next to cc double bond, that is C, next to cc double bond. So that is, this is called an allelic. Okay, so that is allelic. So allelic halide means the compounds in which halogen atom is bonded to sp3 hybridized carbon next to cc double bond. For example, so this is an allelic. So this is a double bond. This carbon will be there here. Okay. So carbon, and then here CH2Cl. So this is a star carbon. This star carbon which is attached to a carbon, this, okay, which has a CC double bond. So this is, this one, no, this is allelic carbon. So this is allelic carbon. Okay, in the same way, in arene, haloarene compounds, so suppose if it is like this, so this is allelic, so not cyclic compounds, this one. Okay, this is allelic carbon. This is not aromatic, sorry. So this is cyclic compound. Okay, so in the same way, if you are seeing again one more example, C double bond C, and then C X. Okay, so this is a star carbon, and this one which is an allelic one. So this is allelic carbon. Understood? So this is the second classification which comes under sp3 carbon. Okay, then so we'll see the third one, benzyl halides. Third classification, benzylic halides. That means sp3 carbon X. So these are the compounds in which halogen atom is bonded to. That means it's a halogen. Okay, halogen is bonded to sp3 hybridized carbon, sp3 hybridized carbon atom next to an aromatic, next to an aromatic ring. So that is benzylic halides. Okay, so that is benzylic halides. For example, if you take a compound like this, we could take CH2 3. So this is star carbon, which is attached with aromatic ring. That is called, it's a benzyl. So this is called, it's benzyl chloride. Okay, so this is called benzyl chloride and benzyl halide. So it may be okay. So this is benzylic benzyl chloride. Okay. So then, if it is like this, if it is like this is not benzyl. This is not benzyl. Okay, this is not benzylic compound. Okay, yeah. So benzyl means CH, this star carbon in the aromatic ring, which will be attached with the star carbon. So that is benzyl. Okay. Now we have seen under the classification of sp3 carbon, that is a single bond compound, alkyl halide. Again, we have seen three classification under alkyl halide, primary, secondary, and tertiary. Then allyl halide, allylic halide, then benzyl halide. Okay, so these are the classification which comes under sp3 carbon. Okay, next one we are going to see. monohaloalkanes. இது எல்லாமே நம்ம வந்து monohaloalkanes தான் பார்க்குறோம். ஓகே, monohaloalkanes ஓட கிளாசிஃபிகேஷன் sp3 sp2 carbon X. Okay, the classification based on sp2 carbon X. So here there are again two classification, again two divisions comes under this one. One is vinylic vinylic halides and another one aryl halides. Another one aryl halides. Okay, so what is vinylic halide? So these are the compounds in which halogen atom is bonded to. Okay, so halogen atom is bonded to sp2 carbon. Okay, sp2 hybridized carbon atom of a carbon carbon double bond. Okay, அதாவது என்னன்னா ஹாலஜன் ஆட்டம் வந்து அதாவது ஸ்டார் கார்பன்லயே டபுள் பாண்ட் இருக்கும். ஸோ தட் இஸ் த டிஃபரன்ஸ். ஓகே, ஸ்டார் கார்பன் சொல்றோம் இல்லையா, ஸோ ஸ்டார் கார்பன்லயே double bond இருக்கும். Okay, so that means the C double bond C. So for example, suppose this is one. Okay, so this is actually carbon. It's a star carbon. The star carbon itself, it has a CC double bond. Okay, so that is vinylic compound. Okay, for example, again, I'll give another example. C. Here I will write C double bond C X. Okay, suppose if the compound is like this, so uh, this is actually it's a hero carbon. So the hero carbon itself has double bond. Okay, so that is vinylic halide. Hero carbon itself has a double bond. So that is vinylic halide. Okay. Then if you take aryl halides, so these are the compounds which in which halogen atom is bonded to sp2 carbon of an aromatic ring. Okay, halogen atom is bonded to sp2 carbon of an aromatic ring. For example, this is an aromatic, no? So this is an aromatic. So this one, all the carbons are sp2. Here, okay. So here in the sp2 carbon itself, if halogen atoms are attached, then it is aryl halides. Okay. So this is an example. So another example also we can give. CH3B. So this is also an aryl halide, but if it is like this, CH2Br, so this is not aryl, this is benzyl, but this is aryl. So don't get confused. So benzyl means this is the star carbon. Okay, star carbon which is attached with the C double bond. But aryl means star carbon itself has a double bond. Okay, so this is uh, the classification of sp2 carbon based on hybridization. Okay, so now we complete the classification of the haloalkanes and haloarenes. Okay, next one. Um, Next one, it's nomenclature. I hope that you are all familiar with the nomenclature, that is IUPAC name. How to write an IUPAC name. So, you learnt in 11th standard. No? So we learnt the classification of halogenated compounds and how these are named in the previous class itself. So here the UPSC name. So before we get into that naming the compounds, So we should know that alkyl halides are named as, okay, halo substituted hydrocarbons, and haloarenes are the common as well as the UPAC names of aryl halide. All just now we have seen all monohaloalkanes. If it is a dihalogen derivatives, how we have to give me? Okay, so derivatives, dihalogen derivatives for aromatic or for aryl halides. How we are going to give name? So for dihalogen derivatives, um, the prefix the prefixes of ortho, meta, and para are used in the common system. Okay, but in the IUPAC system, IUPAC la enna no, it's ortho means it's 1 2, meta means it's 1 3, and para means it is 1 4. So we'll see the example. Okay, um, we'll see the example. So this one. Suppose one halogen is there. So IUPAC name will see that it is bromobenzene. Okay, so this is bromobenzene. If it is two, if it is two, um, here one and here one. So that means the position one and position two. Other one two, one two, one two means ortho. Okay, ortho. Okay, so this is ortho dibromobenzene. Dibromobenzene. So that is ortho dibromobenzene. Ortho-dibromobenzene is common name. IUPAC name 1,2-dibromobenzene. 1,2-dibromobenzene. So this is common name. This is IUPAC. Okay. So this one. Suppose if the position of the second substituent, this is number one position. This is number three. Okay. So this is common name is it's metadibromobenzene, metadibromobenzene, or in IUPAC 1,3-dibromobenzene, 1,3-dibromobenzene. Then if it is like this, here one Br, here one Br, this is para. Okay, para dibromobenzene or 1,4-dibromobenzene, right? So if the dihalogen derivatives, that will be named like this. Okay. So this is what we are going to do. We are going to write the IUPAC name. So in the IUPAC name, so we will see in detail in the next class. Okay. Thank you so much.